A, 2, 1, and B, 4, 3 are 2 points. C is the midpoint of AB, and K is the line through C that's perpendicular to AB. So perpendicular lines meet at right angles. Part 1, find the coordinates of C. Part 2, what is the slope of AB? Part 3, using your answers to Part 1 and Part 2, find the equation of K. Part 4, verify that the point D14 lies on K. Find the distance from A to B and the distance from C to D. Hence, find the area of the triangle ABD. So this is the triangle ABD. And this is C, the midpoint of AB. So part 1, find the coordinates of C. So we're going to use our midpoint formula, which is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. And we're going to use the point A, 2, 1, and label it as x1, y1, and B, 4, 3, and label it as x2, y2. Then we just substitute into the formula. We swap x1 for 2, bring down the plus, we swap x2 for 4, swap y1 for 1, bring down the plus, swap y2 for 3, and both of those are divided by 2 with a comma in between. 2 plus 4 is 6, and 6 divided by 2 is 3. 1 plus 3 is 4, and 4 divided by 2 is 2. So the midpoint of the line AB, or the midpoint between the points A and B, is the point 3, 2. So C is the point 3, 2. Do not add these together. This is the final answer for the midpoint. Part 2, what is the slope of AB? So we're going to label our point A as x1, y1 and our point B as x2, y2. This is our slope formula, m representing the slope, and it is y2 minus y1 divided by x2 minus x1. So we swap the y2 for 3, bring down the minus, swap the y1 for 1, divided by, swap the x2 for 4, bring down the minus, swap the x1 for 2. 3 minus 1 is 2, 4 minus 2 is 2, 2 divided by 2 is 1. So the slope of the line AB is 1. Part 3. Using your answers to Part 1 and Part 2, find the equation of K. So the equation of AB was 1, and since K is perpendicular to AB, the slope of K is going to be minus 1. So the slope of AB was 1, and 1 is technically 1 over 1. And to get the perpendicular slope of a line, what we do is we turn the fraction upside down and change the sign. So this is originally positive, so it becomes a negative, and 1 over 1 flipped upside down is still 1 over 1. And 1 divided by 1 is 1. So that's where we get minus 1 from. So the slope of the line K, which is perpendicular to AB, is minus 1. And we know that the point C is on K, and the point C is 3, 2. So we're going to label it x1, y1. And we're going to substitute this point and this slope into our equation of a straight line formula, which is y minus y1 equals m times x minus x1. So y stays as y, minus stays as minus, and y1 we swap for 2, bring down the equals, m we swap for minus 1, bring down the bracket and the x and the minus, and x1 we swap for 3. So then minus 1 by x is minus 1 by minus 3 is plus 3. And then we can get our x's and our y's on the left and our constants on the right. So bringing the minus x over the equal sign, it becomes plus x. And bringing the minus 2 over the equal sign, it becomes plus 2. and 2 plus 3 is 5. So you get x plus y is equal to 5 for the equation of the line k. This could also be written in the form of y equals mx plus c. So that means having y on the left. So it would be y equals minus x plus 5. So these two equations mean the same thing. Now, alternatively, instead of using the point C, we could have used the point D, because the point D is also on the line. Part 4, verify that D14 lies on K. So if they're saying verify, they're telling us that it definitely does lie on K, and we just have to prove it. If it said investigate if D lies on K, then we wouldn't know if it does or not. So we're being told that it definitely does lie on K, we just have to prove it. So we substitute the point 14 into the equation. So we got this equation from the last question. So our equation of our line is x plus y equals 5. We swap the x for 1 and the y for 4. 1 plus 4 equals 5. 5 equals 5. So since the equation balances, we know that the point 14 does indeed lie on K. So for an equation to balance, it means we get the same number on both sides of the equals. Part 5, find the distance from A to B and the distance from C to D. So these lines mean distance. So we're going to use our distance formula, which is root x2 minus x1 squared plus y2 minus y1 squared. So I'm going to start off by finding the distance from A to B. So I'm going to label my point A as x1, y1, and my point B is x2, y2, and I'm going to substitute my values into my formula. So swapping the x2 for 4, bringing down the minus, swapping the x1 for 2, and all of that squared. Make sure you use brackets, bring down the plus, swap the y2 for 3, bring down the minus, swap the y1 for 1, and all that's squared. 4 minus 2 is 2, and 2 squared is 4. 3 minus 1 is 2, and 2 squared is 4. 4 plus 4 is 8, so we get the square root of 8. So now I'm going to get the distance from C to D. So from C to D. So to get the distance from C to D, I'm going to label D as x1, y1, and C as x2, y2. So the point C is 3, 2. So then I'm going to substitute into my formula, swapping x2 for 3, bring down the minus, swapping x1 for 1, square that with brackets, bring down the plus, swapping y2 for 2, bring down the minus, swapping y1 for 4, and it's squared with brackets. 3 minus 1 is 2, and 2 squared is 4. 2 minus 4 is minus 2, and minus 2 squared is also 4. Because minus 2 squared is minus 2 multiplied by minus 2, which gives us plus 4. 4 plus 4 is 8, so we get the square root of 8. So the distance from C to D is the square root of 8. It just so happens to be the same distance as the line AB. Part 6, hence, find the area of the triangle ABD. So the triangle ABD. So we want to find the area of this triangle. So hence means using what we've already found. So in the last question, we found the distance from A to B to be root 8, and the distance from C to D to be root 8 also. And AB is the base of the triangle, and CD is the perpendicular height of the triangle. So as K is perpendicular to AB, we can use the fact that the area of a triangle is half the base length by the perpendicular height. So to find the area of the triangle ABC, this is what we're going to do. We're going to multiply half times the base times the height. So it's going to be half times the base, which is root 8, times the height, which is root 8 as well. So the area of the triangle ABC is half times root 8 times root 8. And root 8 times root 8 is 8, and half of 8 is 4, so we get 4 units squared for the area of this triangle.